We've talked about grounds and short circuits, and we now come to a related topic, fuses. When we talked about grounds, we said that sometimes the large leakage current caused by a ground might blow a fuse and cut off the supply. We'll now look at fuses in more detail. When a wire carries a current, it gets hot. And the more current it carries, the hotter it gets. In fact, if it's a thin wire with a large current, it will get so hot that it glows, as in an electric radiator. Larger currents still will cause the wire to melt, to fuse, as we say, and it will part. This is the principle of those items of electrical equipment we call fuses. The purpose of a fuse is to protect a circuit from damage if a fault should occur and an excessive current should flow. This is what has happened here. An excessive current has passed, causing the fuse to blow. Fuses are designed to blow very rapidly before the excess current can damage the circuit they protect. There are many types and sizes of fuses, but they are all marked somewhere with the size of steady current they will carry without blowing. This is called the fuse rating. In this case, 150 milliamps. This one is rated at 10 amps. Although they will take a higher current for a very short time, they will blow if currents above the fuse rating flow continuously. When a fuse blows, it must be replaced with another of the same type and the same rating. In circuit diagrams, a fuse is represented by this symbol. It is important that a fuse is in the right place in a circuit. A fuse is always placed between the supply and the circuit it is there to protect. Also, you can remove the fuse and be sure the equipment is dead if you need to work on it. There are two main types of fuses other than rewirable ones. First, there is this type, the cartridge fuse. In a cartridge fuse, the wire is tin copper wire, and it is enclosed in a casing. The ends are sealed into caps. These cartridge fuses are used for currents less than 100 amps, and they have two important advantages. They are cheap to make and easy to change. Their disadvantages are that the climate may affect their ratings, and the voltage supply may be enough to cause arcing across the gap after the fuse has blown. This disadvantage is overcome in the other main type of fuse, the high rupturing capacity fuse, or HRC fuse. An HRC fuse is quite different in construction. In this case, the wire is several strands of silver passing through ducts in an earthenware casing. Packed around the strands is quartz powder. When excessive current flows, the wire melts, and so does the quartz powder near the wire. And because it is a good insulator, no arcing across the gap can occur. HRC fuses can be used at high ratings, up to several hundred amps, and they are accurately rated. Now, we said the fuse rating is the current which a fuse will carry continuously. And it's obviously important that the rating is correct for the normal current flowing in the circuit it protects. If the rating is less than the normal current, every time you switch on, the fuse will blow. On the other hand, to put in a fuse which is rated higher than the normal circuit current is dangerous. Here's a 2-amp circuit wrongly protected by a 10-amp fuse. If there's any fault which causes the circuit current to rise to, say, 8 amps, the fuse will not blow as it should do, because its rating hasn't been exceeded. So 8 amps continue to flow in a 2-amp circuit. The circuit wiring will overheat, and it could easily cause a fire. Many electrical fires are caused by using fuses of too high a rating for the circuit wiring. Used properly, fuses are among the most important and efficient safety devices used in the whole of the electrical field.